So this is the ratio test, and basically you take a sub n, you do a sub n plus 1, you divide that by a sub n, and you take the limit of it, the absolute value. And if it's less than 1, then it is convergent. If it's greater than 1, it's divergent. And then if it equals 1, then it's inconclusive, and you're going to have to use another test. Now we're going to do 3 examples. The first example will be 2 to the n over n squared, and that will be your a sub n. And you're taking the limit of a sub n plus 1 over a sub n, so you're going to add 1 to all of the n's, which would be 2 to the n plus 1 over n plus 1 squared. And you're going to divide that by the original a sub n. And you can actually write this as multiplying by the reciprocal, which is what we're going to do from now on. Now we simplify. 2 to the n plus 1 over 2 to the n is just simply 2 if you subtract the exponents because you're dividing. And then you'll be left with n squared over n plus 1 squared. And if you just look at the first terms, the n's in the numerator and denominator both have the same exponent, which is 2. And if you know the rule, if you have the same exponent on numerator and denominator and you take the limit, it will equal the coefficients, which in this case is just 1. And if you get 1 for that, 1 times 2 is 2, which is greater than 1, which means that it is divergent. Now for example 2. We have e to the n over n prime, which again is your a sub n. Take the limit of a sub n plus 1 over a sub n, but we're multiplying by the reciprocal. Then again, you simplify that. E to the n plus 1 over e to the n is simply e to the 1, or e. N factorial over n plus 1 factorial is going to be n plus 1 in the denominator. And since n in the denominator to infinity approaches 0, the whole limit will equal 0, which is less than 1 and is convergent. For our last example, we're having 6 to the n over n plus 1 to the n. Again, you're going to take the limit of the absolute value of a sub n plus 1 over a sub n, and we're going to multiply by the reciprocal instead of dividing. It makes it much simpler. And then again, you simplify. 6 to the n plus 1 over 6 to the n is simply 6. And then the numerator, n plus 1 to the n, will be the same. And the denominator, I just added the 1's together inside the parentheses, but it's still the same thing. Now, if the denominator's exponent is larger than the numerator's exponent and you're taking the limit, then the limit will just be 0. And 0 times 6 is 0. And that's less than 1, which means this is a convergent series. I just realized I forgot to put a summation in front of all of the examples. So just pretend that there's a summation there.